Hello guys. So whenever people start learning AVR microcontroller programming, they usually start with the basic input-output registers. But has anyone ever tried the debugging method to learn how these registers actually work? So let's check that out. So this is a really simple program. We have defined the frequency of the CPU frequency at 16 megahertz. The input output library and delay libraries are included. So next in the main function we have initialized a variable a, and we have kept it volatile. So initialized to 0, and next we the data direction register for port A is initialized to 0xFF, that is all of them are 1 as it's shown in the comments. Next, the port A register, which decides if the pin in port A should be high or low. So the pin 0 of port A is high. Next, in the while loop, we just keep left shifting the value of port A by 1. So there would be a time where the bit would the high bit would reach the MSB, and then it would shift out of the port A register. So at that time, the value of the port A register would be 0. And also every time we go to the next iteration in the while loop, we increment a++. So let's see how to debug this. First of all, let's build this, and the build is successful. Next, we go to debug, we start debugging and break. Then debug window IO. Here you can select port A and you can see all the port A registers, that is port A, DDR and pin. Next, go to debug, Windows and live watch. So now let's just take it here and right click on A and add watch. So you have add watch out here on the bottom, and next see you have step over at F10. So from now I'll just keep pressing F10. You can see this arrow. This is at a equal to 0, and the value is a random number initially. Now when I press F10, the value is initialized to 0, and the arrow goes to the next instruction. Also, you can see the registers. The 3 registers are not initialized. Now when I press F10, DDR-A 0xFF. So DDR-A has got 0xFF. This is how you can actually see those registers change the values. Next, port A equal to 0x01. In the comments you can also see 00001. So this port A, you can see this is initialized to 1. So you can see pin A also got the same value as port A, 0x01. Now let's step into the next line, A++. The arrow is on A++, and you can see the current value is 0. Now when it executes this instruction, you can see the value change. So the value changes to 1 because A was incremented. Also the port A was left shifted once. So you can also see port A and pin A, the bit is shifted once. Now next, when I press F10, for the next iteration of the while loop, port A has to shift one to the left again. So as soon as I press F10, you can see it shift once. Now it's again on A++. The value of A, as you can see, is 1. So as soon as I press F10, you can see the value being incremented to 2. So this is how you can see the registers working behind the scenes. you have all sorts of registers, from time marker counter for all the peripherals to the 2-wire serial interface, which is also called as I2C. You have timer counters for all the three timers, that is 2 8 bits and 1 16-bit, the watchdog timer, then EEPROM, CPU registers, ADC, everything. So this is a cool way to see what actually goes around behind the scenes. Also, there are many other things that you can explore in this. Also, there's one thing called as disassembly, which I found really interesting. You can actually see what your code is in assembly. Also, next you have the registers, all the registers that you might have studied, that are actually that are actually working inside the CPU. You can access them in then you also have something called as the processor status. The processor status shows you the program counter, stack pointer, all the status registers, the 0 flag, carry flag, all of those basic flags. You can see the frequency at which your controller is operating. Also, you can see all these registers. So can you see R24 is 2 and the value of A is 2. So let's keep this on one side and play with this. Debug window. Okay, yep. Here's my code. Okay, it's currently on line 23. If I press F10, just a second. Okay, you can also see R24 out here. So just keep an eye on that. And if I press F10, the value of A will increase to 3. Also, R24 increases to 3. And you keep seeing the program counter also incrementing. So program counter is looping between 41, 44, 49. You can see that. So things like this is really interesting. I hope you learned something from this today. Thank you.